so dangerous. What is he doing?
Look how much gold there is.
Grab it so fast that the bad guy can't get you and just frisbee it off the boat.
Why didn't the armored truck drivers call it in?
Well, it would at the very least be gamma ray radiation.
Today we're watching Tenet by Christopher Nolan. What did you think?
Tenet, the 2020 film, yeah, I gave it a 3 out of 10. Real harsh, because it's a confusing, what is going on? Okay, but okay, the first parts, the good parts. Good costumes, the sets, the locations are dope. It really felt like this spy movie of like a Bond-esque feeling, like they're traveling around the world in yachts and like dressed to the nines. Felt super good. There are cool twists. Like I did not see that coming where Neil sees protagonists and like there was the mask that came off and like super good. Cool twists about the time travel and very nice. And good try at new sci-fi. So for that reason, I give it a 6 out of 10, but overall a 3. I mean, I got to give them some bonus points for trying something new. And so I really like this sci-fi in that it really feels like science fiction. So they start with a kernel. A little idea. And the idea is that in the second law of thermodynamics, the entropy change should always be 0 or greater than 0. And they said, well, what if that's different? What if we had the entropy change that is negative? And that flips around the arrow of time. Super cool. And then they said, what are the consequences of this? And that's not something that is often done in sci-fi. Modern sci-fi, often sci-fi is kind of like, it just could have been any story that happens to be in the future, or it happens to be in like a zombie thing. But actually, if you like, there's no actual consequences of the scenario. It could have been a romance. It could have been a drama. It just happens to have a backdrop, which is sci-fi, but not really. So Tenet is very good about this. They took a kernel of like a scientific question and said, what if that wasn't true? What if we changed it, flipped it around? And then what are the consequences of that? Super good. And so I want to encourage writers, directors, screenplay people. I want to encourage film people to chase after new sci-fi, because there's potentially great stories that can come out of it. But this movie was very challenging for me. So the cons of this movie is what is the base science? What are the rules about this? So if you're creating a new universe, people being audience are very good at observing and figuring out what the rules are, and then once you establish your rules, they can imagine things and see how people are moving. It's very much like when you watch a new sport for the first time. A new sport, you're like, what is going on here? And then someone explains to you the rules, like soccer. Like, you're not allowed to touch the ball with your hands unless you're the goalie. But then if the rules aren't consistent, then sometimes a forward can touch it with their hands, like sometimes a defender. Like it's very jarring when the rules aren't consistently applied throughout the universe. And so that happens a lot in this movie, where the idea that the entropy is reversed, fantastic idea, but it's not consistently applied. And so this feels to me like science snippets. Like they asked a physicist, what would happen if the arrow of time was reversed? What would happen if the entropy wasn't always greater than or equal to 0? It's like, well, there'd be an explosion, and instead of exploding out, it would collapse in, which is great. But that idea of this reverse entropy should apply to everything, including the fire spreading, which it doesn't. And in this movie, it's very confusing. It felt like there was little bits of science here and there, and you mushed it together. Very, very, very weird. Also as is a storytelling in the movie, it's choppy. I felt like I was in one scene, and then suddenly next scene, and we were different parts of the planet, and somewhere here, and it didn't feel very smooth. And so that was, every time you get this jump like that, it's jarring to me as an audience member. Like, why are we here now? So overall, the movie is very confusing. Maybe that's the appeal. Time travel movies are challenging. However, I think the time travelness of it was okay. It was the consistency that really bothered me. What did you think about this movie?
I give Tenet an 8 out of 10, straight up.
Oh, you're so generous. Okay, it's fine.
I think I am much more forgiving in a time travel movie, because I think it's impossible to get time travel correct.
It's challenging.
So when it's impossible to get something correct, in order to do it, you kind of have to break rules. So I was more happy with inconsistencies, because I think it's impossible to do a time travel movie without tons of inconsistencies. So I was able to mentally brush off some inconsistencies without losing my immersion. So I think I enjoyed it a lot more. And again, I would like to say I appreciate the new IP. I appreciate that they're doing something completely new, and trying something that hasn't really been done before. So the creativity and the newness of it is great. So I really appreciate that. I did get immersed in the movie, so that's great. Sometimes a lot of things take me out. In this movie, I was fairly in it the whole time. Great cinematography. I thought the cast and acting was great. My biggest disappointment was the final scene, which looked like a paintball arena to me, which is like, I don't know. I felt like it needed to be spiced up a little bit with some environment stuff. It felt like I'm going to go down to my local paintball arena and have a match. That's what it felt like. And that scene, that paintball arena scene at the end, was very confusing, to the point where I was like, there are people just running around. I don't know what's going on. But up until that point, I was extremely entertained, loved it. So I'd say 8 out of 10. I enjoyed the movie a lot. All right, let's get into it.
Before we get into it, you have a very good point, the new IP. And so, I mean, I gave it a bonus 3 points for new IP. I think we really should encourage new intellectual property, also new attempts at sci-fi. Otherwise, we just get superhero stuff forever.
Forever, yeah. And it's
not interesting.
I want new sci-fi where the sci-fi is like essential to the story. And this is a great attempt at doing that.
That's true.
Yeah. All right. Well, let's get into it. Start with some danger gains.
So here's the protagonist, and he's on a ship for a while, and he takes care of his physical body, but it's so dangerous. What is he doing? Climb the ladder, sure. I mean, that's good. And then he does this. I mean, pull-ups. Pull-ups. I mean, nothing wrong with pull-ups. Pull-ups super good. Works the back, works the lats. Like, why is he like 30 meters above the ground? He equally could have done this pull-up at like the 5th rung, the 6th rung. Like, if he messes up, little slip, little sweaty hands, like he's going to break his back. What are you doing?
I know he's going to break his back. Okay, let's say you do pull-ups to failure. And now you're 20 meters, 30 meters above the ground. You're like, my forearms are toast.
I'm stuck.
I'm isolated in the ocean.
Like, I don't need to climb to the 3rd floor of a gym to do pull-ups. Like, I can do the pull-ups just on the 1st floor. I just need my feet not touching the ground. What was going on here? I don't understand.
Yeah, well, just do the first rung. Just do the first rung. Like where he's down here. Yeah. First down here.
Get down here. What are you doing?
What's the problem? In fact, if he wants real gains, he should be doing them up here.
That's right. The maximum risk. The maximum risk, because that way, if you have to push yourself. You have to push yourself to work hard. Otherwise, you fall and break your back, and the movie's over.
Oh boy. Didn't make sense to me, but
maybe he just has a short attention span. He was going up to the top to get like a sandwich, and he's like, "Ooh, time to work out."
There's gains on the table right here.
You can never leave them gains on the table. Gotta get them.
Never leave the game. Gotta get them. This is the first introduction the protagonist gets to inverted time with this woman we never see again, who sort of explains negative entropy. Mm-hmm. It's kind of a confusing scene. Let's see what we see.
Aim it and pull the trigger.
It's empty. How?
One of these bullets is like us, traveling forwards through time. The other one's going backwards. It's inverted. Its entropy runs backwards. So to our eyes, its movement is reversed. We think it's a type of inverse radiation triggered by nuclear fission.
So the entropy is running backwards, triggered by, what did she say? Radiation?
Yeah, maybe.
It's a type of inverse radiation triggered by nuclear fission.
Inverse radiation?
So I thought that was just technobabble, because what is inverse radiation? I mean, I guess you could say if something is in forward time and something's radiating out, then if something's radiating back in, then that's inverse. Sure. Okay. For me, the thing that she said there was, she said negative entropy or inverse entropy. How did she say that?
Inverse and
negative
here.
Further back.
Inverse radiation triggered by nuclear. Its movement is reversed. We think it's a type of inverse radiation
further back than that.
By
further back than that?
Yep.
Going backwards.
He's like, how?
It's inverted. Its entropy runs backwards. So to our eyes,
okay,
its
entropy runs
movement is
backwards.
reversed.
Yeah, entropy runs backwards.
So first, I guess we should explain time's arrow. So
okay.
The second law of thermodynamics is that the entropy S, or I guess the change in entropy delta S, is equal or greater than 0. So you have a process that happens, and the entropy should be always increasing in the plus direction. And so this is an example of this is an ice cube. See if you have two photographs. One is a sidewalk, and it's there's like a thermometer, so it's like 106 Fahrenheit outside. And then you have a second photograph, and it's the puddle of water. And so the ice cube is a low entropy state. The melted water is a high entropy state. The atoms are zipping around all over the place. And so times arrow points us in the direction of increasing entropy. So you see an ice cube and then a puddle of water, you can say the ice cube came first, it got melted into the puddle of water. And so that's the times arrow aspect. So if you were to reverse that and you said, if water could go from the liquid state and then form itself up into a cube, then that's reverse entropy. That's entropy going in the negative direction.
So my question would be, in the real world, I think we can reverse entropy for non-isolated systems.
Right.
So like we can take the puddle and make it into a cube.
Yep. Put it in an ice cube tray.
Right. Put it in an ice cube tray, which the entropy for that water is going down, but the entropy for the outside, the rest of the universe, is going up by more. So overall, the entropy of the universe goes up. But we can reverse the entropy of single objects if we wanted
absolutely.
to.
So you put the water in the ice cube tray, and then you pump out all the heat. That's why your refrigerator is making sound. It's the compressor going on every once in a while. And so you're taking all that energy, which is causing the atoms to zip around, causing entropy, right? You take that energy, you pull it out, you shove it out into the rest of your kitchen. You say, rest of the kitchen, you deal with it. So you can locally decrease the entropy. But that's not what she's saying here. She's saying, no, just straight up, don't have to worry about locality, about whether you have an ice box or not. It's just the whole scenario, the entropy is decreasing.
Right. So she said like the bullet itself, the inverted bullet's entropy is decreasing.
Right.
Not like a regular bullet would be, or a regular object where we decrease the entropy in going forward in time. She's saying it's like somehow always going against time.
Right.
There's like a entropy of the universe going in one direction, and the entropy of the bullet is somehow going in the other direction in some fashion.
Right. That's also how I interpreted what she's saying.
Because the water, it's always increasing in entropy. If we turn it around and freeze it into a cube, the entropy goes the other direction temporarily, and then it continues on going higher again.
Once it melts again, I'm sure.
Once it melts again, yeah. So, half, okay.
Okay, so that's the key premise. That's the key, the kernel of an idea, of a scientific idea, is that if you could break the second law of thermodynamics such that the entropy could be the net change of the entropy could be negative, then what happens?
Yeah. Okay, let's continue.
So where did it come from?
Someone's manufacturing them in the future. They're streaming back at us. Try it. You have to have dropped it.
How can it move before I touch it?
From your...
How does that... She said you had to have dropped it, but I didn't drop it. I will have had dropped it.
Yep. Time gets complicated very quickly. Yeah. So I guess what she's going after here is causality, because one of the key tenets in physics is that things happen only after you do something to it. There needs to be a cause for a reaction to happen. Otherwise, some things will be reacting to nothing. What are we reacting to? So she's setting up a rule that you have to drop it. You have to drop the bullet in order for it to later come back into your hand.
That's right. But that doesn't really make any sense because he did not drop it. He inverted dropped it.
Which is picks it up?
Picks it up.
Okay.
All right, here. So it's going to pop into his hand. And if you run time the opposite direction, he will have dropped it.
Right.
But since we're going forward in time with the universe, it looks like the bullet popped up into his hand.
But in the future, he will have dropped it. So that counts in the past. Going forward, time is picking it up.
I think he never picks it up. It's either a drop or an inverse drop. Because he doesn't like pick it up. Like he just drops it.
Okay. I meant pick it up as in like an inverse drop. Is it going into my hand as a pickup?
Oh, I see.
Yeah.
Okay. Let's continue.
How can it move before I touch it?
From your point of view, you caught it, but from the bullet's point of view, you dropped it.
But cause comes before effect.
No, that's just the way we see time.
Well, what about free will?
Bullet wouldn't have moved if you hadn't put your hand there. Either way we run the tape, you made it happen. Don't try to understand it. Feel it.
Protagonist is a philosopher. He went straight to free will. He went way over there.
Well, I mean, that's one of the resolutions of like time travel paradoxes is that determinism reigns, and so there is no free will. Just everything is set in stone.
Can you slow that down and explain that a bit?
So, if you go back in time and do something that changes your history, say you kill your grandfather, which means you were never born, which means you could never go back and kill your grandfather. Well, if you have complete determinism, then everything is already set in stone. So there's no way for you to go back and change history. Whatever you do will already have happened. You had no free will in the matter. So having no free will is a resolution to time travel paradoxes, potentially. So somehow he jumped right to free will. He was like, oh my gosh, free will.
Yeah, this guy thinks very quickly.
Yeah. And then there's so many paradoxes just sort of creeping up here that the woman is like, well, feel it.
Feel it? Okay, yeah. Don't worry about it. Don't worry about it.
Don't try to understand it.
Yeah.
What are you, a physicist? Don't try to understand it.
I mean, gosh, in some sense it makes sense because we live in 3D, we live in XYZ, and we live in time, kind of. But we can go forward and in positive X and negative X, but we can't go negative time. So our brains really don't handle negative time well. We're just not suited for it. So what she's saying is just feel it. You get an intuition. Don't try to analyze it.
Right. Which is kind of the right thing to say because if it would take years to build up a mental or a theory about how this works, and she's got to go do a mission right now, don't worry about it.
Don't worry about it.
Don't worry about it.
Yeah, don't worry about the engineering of a plane. If you can fly it, just fly it. Don't worry about it.
Yeah. In the airport scene where protagonist and Neil, they're going to steal something from the airport, halide gas was an important point in the airport heist. Is halide gas a real thing? Let's look it up.
Oh, this halide gas was for the fire suppression.
That's right. So the halide gas comes out, the fire suppression happens, but you can't breathe it in, which made the guards run away. Yeah.
Instead of splashing water all over the place, because the water would damage the paintings. That's right.
Yeah. So let's read this. A halide gas refers to a gaseous chemical compound where one part is a halogen atom, like fluorine, chlorine, bromine, or iodine, and the other part is another element forming a gas at room temperature. Essentially a gaseous salt of hydrogen halide, like hydrogen fluoride, hydrogen chloride, which are typically colorless gases at standard conditions. Okay. Interesting.
So it's from one column of the periodic table is a halogen atom and then another element that binds to it, I guess.
That binds to it.
Why does that stop fires?
Is it just push the oxygen out of the room? Is that what's going on?
Oh, maybe.
So let's go back to the AI here.
Maybe it's like a strongly bound molecule that combustion can't burn.
Fire suppression? Let's find out. Gaseous fire suppression?
It's inert. Yeah, there it is.
Okay. Where does it say that? Let's search for...
First sentence.
It's also called clean fire... let me close that real quick. So gaseous fire suppression is the use of inert gases and... Gaseous fire suppression, also called clean agent fire suppression, is the use of inert gases and chemical agents to extinguish a fire. So the fact that it's inert pushes the oxygen out of the room, and then the fire has no fuel or oxidizer. Is that right?
Right. So yeah, exactly. So you put gas in the room that is unable to respond to the combustion. Effectively, what they're saying.
I see.
It doesn't. That's a weird way to say it. Hang on. No. That's unable to. So you put in a gas that won't react to the combustion.
Right.
Okay.
Well, I guess the combustion requires what? Fuel and oxidizer. Typically, the fuel is the fuel, and the oxidizer is the oxygen in the atmosphere.
Yeah.
And the halide gas pushes the oxygen out of the room and replaces it with itself, which is now inert, which is not an oxidizer,
doesn't-
and you just have fuel,
Exactly.
which cannot combust. Is that right?
Exactly.
Okay. Okay. So when they're talking about halide gas, this is a real thing in the real world that's used as fire suppression. And I guess they didn't want to destroy the expensive art because rich people be important. So they use this gas system instead of sprinklers or foam or something.
Mm-hmm.
Okay.
I wonder why it's not used in residential. Oh, okay, because people would suffocate.
Oh, yeah, people suffocate.
And then also you have to have pressurized gas systems ready to pop at any time. Just use sprinklers.
Yeah, and then that can tie right in, I guess, to the normal water system, which is much easier instead of having this like separate flow. Yeah. Okay. This was weird. Before the airport heist, they talk about the intel that they're going to use for the heist, like different, logistics about the heist and timetables out in the open. What are they doing?
So how do we get enough firepower through the perimeter to trigger the lockdown procedure? That call of the Freeport?
You got something.
Not gonna like it.
You want to crash a plane?
I would have run a jet off the taxiway, and breach the rear wall, and start a fire.
So their plans to crash the plane, to breach the thing, to cause the fire, to do they're out in the open, and they have time agents potentially everywhere, like listening in with parabolic mics, or a passenger on this like tram thing at the airport, right here.
Right.
Just this dude, this person right here is like, hey, I'm listening.
The plan itself seems fine.
Seems fine.
Seems like, in fact, quite clever. But they're just talking about it, and they don't know who's on the enemy team. Like random people here could be listening in, and even if they're not necessarily enemy team, they could just tell their friends, like, hey, people on the bus were had this weird conversation, and like that person may know somebody. So they really should have this conversation in like a soundproof, super quiet place. And as you said, we're dealing with people that could potentially be traveling backwards through time. Like you don't know who they are, and also, if someone in the future was like, oh, this plane went off, that means that somebody planned it. We should go backwards in time and just look for the people that made the plan. They're super vulnerable out here.
That's right. And there's a turnstile in the airport, so people are going to be on people are going to be on high alert as to who's messing with this airport. Very weird to me. It's bad OPSEC, operational security. And then during the heist, this guy is able to push gold out of the aircraft. Gold is heavy.
Gold's super heavy.
Can you push gold? Look how much gold there is.
I mean, gosh, you definitely can push gold. I guess the question is, how much is there?
How much is there? Yeah. So we got a little calculation here. How heavy is this one pallet? I mean, he's pushing multiple pallets.
That's right.
How much is one pallet here? Okay. So first thing is, how heavy is a gold bar? A gold bar is 400 troy ounces. I guess that's what defines a gold bar, which I have no idea what a troy ounce is. Ridiculous units. So we looked this up. It's 12.4 kilograms, about 27.4 pounds.
Okay. 27 pounds. Okay, I know what that feels like.
Okay. And then so if we can count the number of bars, then we can multiply these together to figure out how much a pallet weighs.
How'd you get that number?
So I counted.
Oh, okay.
All right, ready? Across the bottom here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
12, okay.
Okay. Vertical. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
12 by 10.
And then depth. 1, 2, 3, 4, 5, 6, 7, 8.
12, 10, 8.
Yeah. So that's how many, if we multiply those together, just like a volume calculation, we get 10 times 12 times 8, 960 gold bars.
Okay.
Okay.
So now you get the total mass. You have 960 bars times 12.4 kilograms each, and that comes out to be just shy of 12,000 kilograms.
Yep.
What is that? Okay, pounds, perfect.
Yeah.
So 26,000 pounds. I mean, that's enormous.
That's a lot.
Yeah, but help me visualize. Perfect. Oh yeah, nice. You planned this. Okay, so I can convert this into cars. So a sedan is about 2 tons, a regular 4-door car. So so 2 tons, but 1 ton is 2,000 pounds. So each car is 4,000 pounds. So 26,000 divided by 4,000 is 6.5.
6.5.
Yeah. So each perfect. So each of these pallets is like pushing 6.5 cars.
Right. So if we look at this guy over here,
this
pushing.
guy trains sled every day. He's got
Every
3 of
day.
these.
Yeah, he must be doing like squats on a super high elevated platform in super danger. But he's pushing 1, 2, 3, maybe 4 pallets. That's 4 times 6, say. 4 times 6, 24 cars. Maybe 26 cars because there's a little extra.
This guy's got nothing but quads and glutes. Like this is all his body. It's just bottom heavy dude.
And he's able to push it out the back of the 747. I mean, this is a lot of weight crashing out of the plane. Down. Holy crap!
Those gold bars are messed up because gold is a soft metal, so like they're getting chipped. And also, why they're spread all over the place? Why is it?
That's right.
Okay. This scene bothered me not because of the mass, although you totally should have now that I see it. You pushed like 20 something cars, but just that they're loose.
They're loose. Yeah.
You got a pallet. Like why are we not putting? Why is Norsk Freight transporting gold bars in just loose?
That's
Put
right.
them in a box.
As soon as it falls, the gold bars are coming loose. They're falling.
Right.
They're separating. That means, if we look at this, these straps are doing nothing.
They do nothing. Look on the right.
This one?
No, further to the right. Not even on this pallet. Look to the right.
Yeah.
See that wood box?
Yeah.
Put the gold bars in a wood box. Put them. Look on the left. Look on the left. Look on the left.
Look left. Okay.
Wrap them up. Wrap them up. Saran wrap. What is Norsk Freight doing?
Right. Your heaviest, most precious cargo is loosely held together with straps.
There's flight problems with this because if the flight takes like a hard bank and then one brick falls and then they could start a cascade, now you have shifting weight inside your plane. Like the pilot needs to go through here and see like no, like this can't transport like this. We need to secure it all up.
Yeah, as far as I understand, if you have a cargo plane, you're supposed to have a load master, I think it's called, where he's like everything's secured down. Because if you have a shifting load in flight, you're going to crash.
Right? Like if you're trying to take off and then all these gold bricks are falling to the back of the plane, you very quickly fall backwards and you've lost your flight characteristics.
Yep.
Yeah, there are like videos of this. It's terrible.
Really, it's terrible. Yeah. Did they loosen them? Did he loosen the straps? Maybe they were tightened down, and he's like, loosened them?
My job is to push these gold bars out the back, but I'm gonna make it dramatic. I'm gonna loosen the straps, like rain in gold. Just push the thing out. Yeah.
He wanted this little it's rain in gold effect to scatter the gold all over the runway.
When else are you going to get that chance?
That's right. Well, would he have had that chance? Because he wouldn't have been able to push him because gold's heavy.
He's got just quads, glutes, hams, calves,
just all day.
Just push it.
He's just a beast. So this is after the airport heist, and Neil and the protagonist are talking about Feynman and Wheeler. Let's see.
There's a Cold War.
Nuclear.
Temporal.
Time travel.
No. Technology that can invert an object's entropy.
You mean reverse chronology? Feynman and Wheeler's notion of a positron is an electron, moving backwards in time.
So this idea of Feynman and Wheeler, the electron and positron being the same, but one moving forward in time, one moving backward in time, is that the kernel of the idea? Electron, positron, what is it? Feynman
and Wheeler.
Let's see if this comes up here. In the context of physics, when discussing electron, positron, Feynman, Wheeler, it refers to the concept that a positron can be viewed as an electron traveling backwards in time. Okay.
I'm okay with that. And I'm okay with that even in the non-space-time bendy stuff. Even if we just think about it in terms like normal everyday electronics, we have a current going in the positive X direction, but it's actually that's like the positive current, but we've actually misnamed the electron in physics. We made it a negative charge. So what's actually happening is electrons moving in the other direction. And so I'm okay with if an electron going in the negative x direction effectively looks like a positive charge, a positron going in the positive x direction. I'm okay with that.
Yeah, I guess the weird thing is in an inverted object, it's going backwards in time. All the electrons in the inverted thing should be positrons, which when they interact with an electron, there's an annihilation event. But we don't see that, so it's not quite the same thing as this, I think.
I didn't finish my idea, actually. I gave up. So I'm okay with even this positron idea. So it's I gave this example of positive charges going this way, positrons, and negative charges going this way. But that was all still positive time thinking. But if we now do a time reversal symmetry, so if we, instead of having positive charges like going this way, it would be positive charges going the minus x direction. But that's with time reversed. But that's the same thing as a forward time electron with a negative charge. So mathematically, all the same. An electron going in the positive direction in positive time is the same thing mathematically as a positron going in the negative direction with negative time.
So I think this leads to this one electron universe idea, which
This
is
is weird.
wild. So, okay. So let's see if we can get to... It says, I did not... let's see.
Well, let's start with the top.
Start with the top,
What is the one electron universe?
The one electron universe postulate proposed by theoretical physicist John Wheeler in a telephone call to Richard Feynman in the spring of 1940 is the hypothesis that all electrons and positrons are actually manifestations of a single entity moving backwards and forwards in time. So this is an explanation for why all electrons are identical, is because they're the same one. And it can do this, be in an unbelievable number of places in the same time in the universe, because it just goes forward and backwards in times a bunch of times, so that's simultaneously everywhere in the universe, which is a wild idea. I don't think it holds up to scrutiny because the amount of antimatter is not equal to the amount of matter. So that means the number of times the electron's going backwards in time is not equal to the number of times it's going forward in time. So I'm not sure how that would work, but it's a cool idea.
It's a cool idea, and I don't think it works in reality. However, it does explain this movie. So, for example, Neil seems to have different amounts of information at different times in the movie, and it's not like as the protagonist is going forward in time and learning things, and Neil is also learning those things. It's sometimes Neil knows more and knows less, and it's not like in forward time, Neil's always learning more. It's all over the place. So this might be explained by Wheeler. Neil is time traveling, but he's not time traveling like straight back. He's like jumping back and forth, and so he's hitting different times inconsistently. Which is analogous to that positron jumping back in time, and then it can be in multiple locations. It just needs to jump back more times.
That's right. So currently, protagonist is interacting with this Neil, but there's other Neils in this particular time at different locations doing their own thing.
Yeah.
Yeah, it's super weird.
Cool. Maybe.
Yeah, cool.
So on the boat, this is the painting that the wife had mischaracterized. And so the bad guy has been holding this over her head to keep her in prison. But look at this. Look where she is.
Were
There
you
it
worried
is.
it had been destroyed? Rest assured, instinct told me to remove it from the vault. I've always had instincts about the future. That's how I built this life you no longer value.
Like, this painting is holding her tied to him. He's using it as leverage so that she can never run away with her kid. But she's on a boat. just frisbee it. Just grab it super fast. Grab it so fast that the bad guy can't get you, and just frisbee it off the boat.
Yeah, like right here. It's sitting right here. Just frisbee it.
It's gone. Like, right? And what is he going to do? Is he going to like dive and get into the water? Like, I made you dive in front of the water. Like, right? Like this is a no loss scenario. The only way she could have failed the scenario is not do anything.
That's right. Even if it was a copy, which she doesn't know, if she still frisbees it off the side. Well, she ruined a copy. She took the chance that it would destroy the piece of art, but it wasn't. It was a copy.
She
But
gets,
she
even
gets
if
to-
it's a copy, she gets to be indignant in front of his face. Like, still a win.
And you get that nice frisbee throw. It gets that nice curve to it.
Yeah, right.
Hell yeah.
Heck, maybe it's laminated. I'm not sure. Maybe it's a little shiny there, right? So maybe it is sealed or something.
Actually, there's a good picture right here. I think it is laminated and sealed up.
So maybe it doesn't get damaged by the water, but
Mhm.
it's still going to sink, right? Is he going to get this off the bottom of the ocean?
Yeah, no way. Even if it is sealed, is it like sealed tight, or is it just like a protective cover?
That's why I went with laminated. Laminated is like heat sealed tight.
That's
Should
right.
be
Yeah,
fine.
should be fine. Yeah.
But like frisbee it into the ocean. You got to like 30 yards into there. It's like, hey, he's not going to get
Yeah.
that.
Yeah, no way. He could
Weird.
send one of his people down there, but
Bottom of the
No way.
ocean. I guess. Yeah, maybe he's got a submarine built in his yacht.
it's like a James Bond villain almost.
He's got a James Bond. Heck yeah. If I had a yacht, I'd have a little submarine in there.
Yeah. Yeah, that's the move. Frisbee it.
All right. Just off the boat.
Yeah. This is the scene where they take this the device off of this, I don't know, Brinks truck.
Brings like
It was
the
cool.
armored truck stuff.
Yeah, the armored truck stuff. I was blown away. Why didn't the armored truck drivers call it in? They get like slowly surrounded by these trucks, and they don't call it in until the jamming gets turned on. I was wondering, are these guys trained?
You call in that they're getting surrounded to
Yeah.
to like their support team somewhere, I guess.
Yeah, I assume they have a dispatch somewhere.
Oh.
They're like, something weird's going on. Trucks are getting too close.
Well, I guess in order to call in that you're in danger, you need to first know that you're in danger. So I guess from their perspective, they may be okay, right?
But wouldn't they get a feeling like these trucks are hemming us in?
But that happens in traffic, right?
And it does happen in traffic. How dense is the traffic?
Yeah. Okay. Yeah. So, but yeah, this is in a helicopter's view, right? The guys in the trucks are not in a helicopter. They don't know, right? So
Right.
they're close up to the car in front of them, and that's on them. They're tailgating.
Yeah.
But that severely limits their view, right? Like they don't know it's empty in front of them.
I see. So you're saying the heist people are simulating heavy traffic, surrounding.
They just don't realize that they're not in heavy traffic.
Yeah, I see it.
Heck, even the guy
Okay.
behind him. The guy behind him, like you know when you go behind these trucks and it's like stay back because my mirrors can't see the right angle. Like, they can't
Yeah,
see
that's
the
right.
angle to
Yeah.
see. Like you got to stay behind trucks like a good
Yeah.
I don't know 20 yards or something. Stay away. So they may not even know that truck behind them is there.
That's right. So they see one truck in front of them. They see nothing to the sides here,
Yeah.
and then they see truck. This sort of diamond shape of the trucks happens so slowly that I was
Yeah.
surprised that the Brinks truck wasn't like, this is a situation here.
Yeah. Have I told you about the parable of the frog in the water?
No.
Oh, it's just if you boil a frog slowly, it dies in there and doesn't realize that it's heating up. But if you drop it in hot water, it's like hot. I'm out. I don't like
I
this.
see.
Right. So if these trucks close in real slow, maybe that truck in the middle didn't realize it was happening.
Didn't realize what was happening. Okay.
I mean,
Okay.
the two trucks on the sides are super close. Like that's super close. Like,
Super
stop
close.
touching. Oh, and the guys on the left, that's a fire truck, right?
Yeah. Well, at this point the trap is sprung. It's just there was a time where there was like 2 trucks and then 3 trucks.
Yeah, it happens slowly. And the guys on the left are fire truck. Like fire trucks are friends. Like,
Yeah,
why
coming to
should I be
rescue.
worried about them, right?
Yeah. And then after the heist, this is protagonist's first inversion through a turnstile.
You'll need your own air. Regular air won't pass through the membranes of inverted lungs. Don't come into contact with your forward.
So why doesn't regular air work with inverted lungs? That seems weird to me.
I don't know. The best guess that I had was that if we're going for this theory of if in the inverted world we're swapped with all the antiparticles, then it's possible that we now have negatively charged, or I guess we have antiprotons for oxygen, and then we have positrons on the outside. So now the electronic shapes. I guess the bondings don't work anymore because when hemoglobin or the lung barrier is expecting a negatively charged oxygen to go through, and then it encounters a positive thing, it's like, what is this? I'm not letting you through, I guess.
Yeah, the only issue I have with that is if it's true that the inverted matter is like antimatter, then it would just get annihilated in the atmosphere of Earth.
Yeah.
Because, right, antimatter and matter, when they collide, there's an annihilation event.
Mm-hmm.
But as soon as he hits regular air, he doesn't explode.
Right.
In fact, that explosion would be like really, really large because you'd have a conversion of his body mass to energy, which I think would like blow a hole in the Earth.
Well, it would at the very least be gamma ray radiation, and so all his other organs would get messed up. It would happen very quickly, I think. Oh yeah, I think it would happen pretty quickly.
I don't have an intuition about matter antimatter explosion conversion rates when they come in contact.
Well, I guess so when we touch things, that's the electric force, right? You touch electrons to electrons and they repel, and then you can't just smush your finger through itself, right? But that's because they're negatively charged, so they repel each other. And so if we had electrons with positrons around, they're now positively charged. So as long as they're close enough, they can attract and then annihilate. You get an electron, positron come in, and then 2 photons that pop out.
Sounds like it would happen extremely fast.
I'm not a high energy physicist.
So I don't think it cannot be converting to antimatter in the turnstile, because I think we're talking about annihilation. So it has to be reverse entropy, but while staying regular matter.
I guess.
Has to be.
I don't think so because of what she says next.
Self. It's the whole point of these barriers and protective suits.
Oh, we don't have
suits. Protective point of these forward self.
Okay, I'm gonna get this. Here we go.
Lungs don't come into contact with your forward self. It's the whole point of these barriers and protective suits.
Oh, we don't have time.
Well,
so she says, don't come in contact with your forward self.
Let it play like 2 seconds more.
if your particles come into contact,
What?
annihilation. When you
Annihilation would happen.
I think that's matter antimatter stuff.
But it's not like with an antimatter matter explosion or conversion to gamma rays that it's like, oh, you're not my inverted brother,
That's right.
therefore I'm just going to pass right on through. No, it's like any matter antimatter will be like
Any correctly paired. So any positron and electron, or any proton and antiproton. I get that goes backwards, but it's not like if we pair produced an electron and positron. If this positron encounters a different electron, it's like, no, you didn't come. You weren't created with me. Like, I'm not gonna. If that was true, we would see lots of antimatter around the world right now.
That's right.
So I don't know what this is.
Somehow it's like his atoms interacting with his inverted atoms does something real bad. But if his inverted atoms interact with, a bird or a cat or the air, like not a big deal.
Or like the floor he's walking on right now.
That's right. It's not a big deal. It's weird, but I don't have an explanation.
I don't have an explanation for it.
You exit the airlock, take a moment to orient yourself. Things will feel strange. When you run,
Reasonable.
the wind will be at your back.
When you run, the wind will be at your back.
Okay.
That's just some sort of statement about time is inverted. So when you're running forward, inverted forward, the wind is going to be at your back. Whereas if you were running normally, forward in time, the wind would be in your face.
I mean, but I've ran with like a strong wind behind me. Like, right? Have you ever like longboarded or like ride a bicycle with like a strong wind behind, or sailing? That is sailing, right? The wind pushes you forward.
So what you should have said is your airspeed will be inverted because it's all relative to the air. So like if you say there's no wind and I run forward in time,
okay,
then the wind will be in my face.
Yeah, I'm down with that.
But if I'm inverted and I run forward, the wind will be at my back.
Yeah, okay, yeah, I guess that's what she's saying.
Yeah, and
How do I
then
run
you have
forward
to
now?
adjust it for airspeed. If there's a wind, You have to do the Galilean velocity
Okay.
transformation all opposite.
She's doing these if you're running inside like a sports arena where there's no wind. Okay. I'm
Yes,
aboard that.
yeah.
Gravity will feel normal, but if you're reversed for the
So gravity being normal, even if it's reversed, so that means stuff is still falling down
Okay.
towards the center of the Earth. It's not falling up. You'd think
Yep.
it would fall up. But it kind of falls up, like when he caught the bullet,
Mm-hmm.
the inverted bullet, it fell upward.
Sure.
But then most inverted things fall down.
Yeah, because otherwise, in the next scene when they're doing like a car chase, all the cars should just be leaving the planet.
Leaving the planet. So somehow gravity works. It's always attractive, either inverted or not inverted. It's always two masses always attract each other.
I'm okay with that, especially
okay with
because there's no anti-mass. The gravity is attractive from mass particles. They pull each other, but there's no repel particle for mass.
Right. For some reason, that's how nature
Yeah.
works. So that still holds when you're going backwards in time. I'm okay with that.
I'm okay with that.
world around you. You encounter fire, ice will form on your clothes.
So when you encounter fire, ice will form on inverted clothing.
Okay.
I guess that makes sense.
So I think that's a statement of the arrow of time. That's a statement of the entropy is reversed. So when you have like a wood block and then you set it on fire, it's going from the low entropy state of wood to the high entropy state of burnt atoms flying around in the air. Right.
Yep.
So if you reverse that, now if you had a fire, it would assemble itself into wood. And so what she's saying here is instead of things getting hot, they get cold.
Mm-hmm. And so what is hot? Hot means when you go forward in time, you do a chemical reaction.
Mm-hmm.
Energy is released from the chemical reaction by whatever's happening.
Right. Into
and that
kinetic
heats up the
energy, which
environment.
makes it hot. Right.
Yeah. And then an endothermic reaction going forward in time is one where the reaction pulls in energy from the outside and does the chemical reaction,
Makes
and
it cold.
the environment gets colder.
Mm-hmm.
So if we invert time,
like ice packs.
yeah, like ice packs. Yeah,
Okay,
exactly.
okay.
So if we invert time, endothermic reactions become exothermic, and exothermic reactions become endothermic.
Yeah, that's tight.
Okay,
I
sounds
like it.
good.
Yeah.
Okay.
The transfer of heat is reversed.
Can I drive a car? Cowboy shit.
I can't vouch for the handling. Friction and wind resistance are reversed. You may experience distortions.
So cars would be really weird. I don't know if what you're like driving forward and backward through what? I can't even comprehend it.
I don't get it.
You like turn left and so you go right because you're going. I don't know if I understand it. Somehow he drives forward.
But I think people have done this. Like I saw a YouTube guy, he put on like inverted mirrors or maybe this way mirrors, and then he's like, I'm going to learn how to he had a bicycle where he put some mechanical linkages so that when you turn to the right, it would turn to the left. That's something slightly different. What I was thinking about was this other experiment with cats. And so they strapped the scientists, I don't know what type of scientists, they strapped these mirrors on these cats. And so left is right and right is left. And for like maybe a few hours, the cats are like, what the but then they actually adapted very quickly and figured out they could walk pretty normally after they realized that everything was backwards.
Right. Isn't that weird? The brain is like, yeah, okay.
Okay, I'll work with it.
Okay, yeah. So, but he just protagonist dives right into the car and sort of is able to drive right away. It would probably take an hour or two like the cats, I would think.
Way more. Yeah, maybe. Yeah, hard to say even more. I don't know.
Inverted time. I'm not quite sure all the consequences of driving. Friction is wrong, right?
I think she'll say that. I don't know if she said it yet though.
In your vision and hearing, this is normal. You are inverted. The world is not.
Boat's flying backwards.
This is cool.
Inverse step, that was cool.
Yeah.
Boat's going backwards, that's cool.
Mm-hmm.
So we're looking
but the sound still came from the boat. I guess maybe the sound was coming from behind him and they got sucked into the boat.
That's right. So what is there for emission of light, there's the forward light and the retarded light. And so he's hearing the retarded sound that's coming from behind him.
What do you mean the
whooshing
retarded
past him.
light?
What's that?
What do you mean the retarded light?
That is the light so there's, for everything, the light gets emitted forward in time.
Okay.
There's also something that comes in from the past.
Oh, I see what you're saying.
Oh, I can't remember now.
Special relativity.
Yeah. And I think that's thrown out sometimes. I can't remember. But you're saying that the sound, instead of being emitted from the boat going into his ears and past,
Yeah.
it's actually coming from behind him into his ears and back to the boat.
I guess so.
It has to
Right.
be, right? Yeah. It was a cool scene. It felt really weird.
Yeah.
Especially that step was like, whoa, that is interesting. Go ahead. Okay.
Okay, I was coughing.
Okay.
So yeah, so it feels really weird because the human mind, the human eye is very good at seeing the arrow of time and very good at seeing effectively the second law of thermodynamics. Like, you know what a before state is, and then like, say you have a bunch of marbles on a trampoline. Like, if they're all sitting there and not disturbed, you know that's a before thing, before the kid jumps on the trampoline and the marbles are all over the place. Right? So same thing with that puddle. Like, you know what it looks like for water to be disturbed. And so when we see it backwards, already disturbed before the thing happens, yeah, super weird.
Super weird, yeah.
But people are good at physics.
Yeah. And I think that's why it's one of the big problems with time travel is that the puddle shouldn't react before he steps. Otherwise, he has to, like, the lineup of events where the puddle is reacting right where his step is happening. The mathematics, the probabilities of that happening are so low that I don't think it can be possible.
I mean, I'll caveat what you said about time travel. It's specifically this type of negative time. It's because if you jumped back into 1984 and then walked forward in the time, things would be the normal, right? It's specifically this time goes backwards that looks really weird.
Yeah, really weird.